Hello. This particular video is intended for high school honors physics, particularly my high school honors physics, but should be able to be adapted for any science course. Let's dive in. So, science is the study of nature's rules. When I say study, we include making observations. We can't control the movement of the planets, but we can observe their movements, and we can create mathematical models to describe our observations. The study of nature's rules is what physics is all about. So even though we can't control the planets, like I said, we can observe their movements, and we can describe their movements, and we can utilize the mathematical models we develop to describe their movements to our benefit. If you think about how we have our own artificial satellites we've put into orbit, we can look at the moon and we can understand the way the moon moves, much like how Newton recognized that same force that's governing that apple, causing that apple to fall to the ground, that exact same force is working on the moon, keeping the moon falling around Earth. Before Newton, a lot of people believed that there was a different force acting on celestial objects than there was acting on terrestrial objects. So by making these observations, we can discover mathematical models that do a very good job at describing our observations. Okay, another example of this is understanding the natural world allows us to discover ways to exploit natural laws to our advantage. Looking at this beautiful waterfall, think to yourself, what's a way that we can exploit a natural law that's happening here? Looking at this falling water, we can obviously find ways with maybe a water wheel, we can stop this water with a dam, hydroelectric. There's many ways that we could probably exploit this. This is such a beautiful waterfall, I don't know if I would particularly want to interfere with this one, but that's something to consider. So there's other situations that we can observe and we can find ways to also exploit to our advantage. In this picture, if you look at this beautiful scenery, you'll notice some steam coming up in the distance. Right, this represents geothermal energy. That's a geothermal power plant. Geothermal energy, we're talking about the Earth heating up water. The Earth is heating up water. It's giving thermal energy to that water, and we are finding ways to harness that energy in the form of steam. Steam can be used to do mechanical work, and mechanical work can be used to produce electrical energy. We can also produce steam from nuclear energy. We can use solar energy directly with solar panels. By understanding the natural world sufficiently well, we can make physics work for us. It's also possible to use our observations of nature in other ways. For example, we can circumvent natural selection by using modern medicine. For example, surgical intervention, pharmacy, gene therapy. There's many other examples of this. All right. We can find ways to utilize technology, making observations. We can utilize those observations to change things. In years past, complications in pregnancy commonly led to, death of baby, death of mother. But now we have surgical intervention. We can intervene. Understanding human physiology well enough, we know how to keep both mother and baby alive. There's a lot of illnesses that exist that are no longer a cause of death because we utilize pharmaceutical intervention. And then, of course, there's gene therapy, other ways to intervene, to use our observations of nature to put nature to our advantage. Another example is the internal combustion engine. We don't always necessarily have to work and live in the same town. It's now possible to work and live in two different towns. And there's different ways of transportation that can make this very convenient. Physics includes the nature of the most basic concepts, including things such as sound, light, composition of atoms, heat, energy, motion, matter, force, and there's many others that are included in physics. But these concepts are considered to be elementary or basic. The study of science branches into the study of living things and non-living things. Living things and non-living things. So living things includes the life sciences, which includes biology, zoology, botany, etc. The study of living things, that's life sciences. The study of non-living things, we're not saying dead living things, we're saying non-living things. Physical sciences, we're talking about earth science, we're talking about astronomy, chemistry, physics, etc. And there's some overlap. Obviously, as you know, earth science includes biological systems. We're including the biosphere, which actually includes living things. But we're basically saying we separate these into these two different categories: life sciences and physical sciences. And there's obviously overlap as well with chemistry, etc. The most basic of all the sciences is physics. So it's the most elementary and basic of all the sciences. Chemistry is how matter is put together, so we're getting a little bit higher in complexity. Whoops. And then of course there's biology. Biology is very complex. Biology is very fragile. It involves matter that is alive. And most of the time it can't exist in very many different ways. Whereas physics, there's a lot of different ways to describe physical systems, and those physical systems can be manipulated and still exist just fine. Chemistry as well, it's very durable. Whereas biology, you change a biological system very slightly and it ceases to be alive. Biology is very fragile. Biology is very fragile, very complex. So mathematics is the language of all science. By expressing scientific findings with mathematics, the verification of those findings is far easier to verify and or disprove. Mathematics as the language of science. Mathematics makes scientific ideas unambiguous, succinct, and verifiable. It's very important to be unambiguous. We need clarity. We need to know the difference between ideas. An example of ambiguous is if I told you to spell there, right? Phonetically, there's 3 different possibilities, 3 different words, 3 different meanings, 3 different spellings, but they all sound exactly the same. That's an ambiguous statement. I wouldn't tell you to spell the word there without giving you some context. Being succinct means trying to use as few words as possible, trying to be as clear and distilled down as possible to give something that's very thorough, but yet very short and sweet. That's succinct. And verifiable, it's important in science generally to be verifiable, because if you're not verifiable, it's not technically science. And this leads us into the scientific method. So the scientific method, there's probably infinitely many ways to describe the scientific method, and so I feel like this is the most succinct and unambiguous way of describing the scientific method. The first step, identify a problem. Formulate a hypothesis or make an educated guess about the answer to the problem of the first step of the scientific method. The third step would be to predict the consequences of your hypothesis. The fourth step could be to carry out experiments to test your predictions. And the fifth step would be to analyze the results of the experiments that you just did in light of the identified problem, hypothesis, and predictions. And this kind of loops back, and you want to make sure that you are using your experimentation to provide evidence of the validity of your hypothesis. That's the key here. Evidence. The scientific method is widely accepted for gaining, organizing, and applying new ideas, especially scientific ideas. Galileo and Sir Francis Bacon are commonly credited for the scientific method and its development. If a scientist finds evidence that contradicts a hypothesis, law, or principle, the hypothesis, law, or principle must be changed or abandoned. And when I say changed, I mean reevaluated, retested. Maybe new experiments are merited to be able to test the validity of whatever that hypothesis, law, or principle might be. A scientific hypothesis is an educated guess that is not fully accepted until demonstrated by experiment. This is how you provide evidence for your hypothesis, is by doing experimentation, proving it. A scientific theory is a synthesis of a large body of information that encompasses well-tested and verified hypotheses about certain aspects of the natural world. And notice the bolded text. Okay, we're saying the theory encompasses well-tested and verified hypotheses about certain aspects of the natural world. This is what a scientific theory is. I've heard people suggest that a theory is a hypothesis, and it's not. A theory is not a hypothesis. A theory is a synthesis of a large body of information that has been well tested and verified. Hypotheses that have been well tested and verified. So we have experimental evidence. In science, a fact is a close agreement by competent observers who make a series of observations of the same phenomenon. So repeated results that show close agreement. When hypotheses about the relationship among natural quantities are tested over and over, and over and over and over, and are not contradicted, they may become laws or principles. When must a scientific hypothesis, law, or principle be changed or abandoned? And that's when you find contradicting evidence. All right, scientific hypotheses. A hypothesis must be scientific. To determine if a hypothesis is scientific, we need to determine if there is a test for proving the hypothesis right or wrong. If there is no test to prove a hypothesis wrong, the hypothesis is not scientific. So what we're saying is there has to be a test for possible wrongness. There has to be a test for the possible wrongness of the hypothesis in order for the hypothesis to be scientific. All right, so science and technology. Let's talk about how they are different, how they are the same. If you want, you can draw your own little Venn diagram. Let's just dive in. So in order for something to be science, or in order for something to be considered science, I should say, it has to do with discovering facts, relationships between observable phenomena in nature, and with establishing theories that organize and make sense of these facts and relationships. So science is more focused on facts and relationships, whereas technology has to do with tools, techniques, and procedures for putting the findings of those facts and relationships to use. Okay? So science is the facts, technology is how to use those facts, how to exploit those facts. That's technology. Science versus technology. There's also a few different ways to look at the world. So from a science standpoint, science is mostly concerned with discovering and recording natural phenomena. The arts are concerned with the value of human interactions as they pertain to the senses, and religion is concerned with the source, purpose, and meaning of everything. In other words, science is the domain of cosmic or natural order. Religion is the domain of cosmic or nature's purpose. So those are ways to think about those as two different things. And that's okay. It's okay that science and religion are not the same thing. All right, I hope you enjoyed the video. I hope this helps. If you have any questions, go ahead and ask me. And thanks for watching.